I've got solar lights scattered pretty much throughout the house. So during the day, they just collect the sun, and well, not yeah, there's not much sun down here really, but I think we've seen this circuit before. In terms of collecting some solar light, and you've got your QX5252 here. You've got a Xena, so I usually use like a 5 volt or a 6 volt Xena. You've got your 1N5817 Schottky diode, a 47 microfarad capacitor, and these guys now blowing out to around the 300 microhenry for the inductor. A 1 watt LED hidden underneath this Fresnel lens, and so it's not too bad. I mean, this one needs a bit of repair, so it's a little bit manky at the end of it all, but I'll fix that up. But I'm actually going to, I'm just trying to figure out whether there's a resistor in there or not. I can't remember. I probably would have put like a 100 ohm resistor in there, but I'll have to investigate that. But yeah, so these are all over the house, and they just collect a little bit of light during the day, and then they'll go for like literally 2 days, lighting the way. So you don't have to flick on any lights as you go throughout the house anywhere during the night. So that's pretty cool. But I've just discovered or taken delivery of these new, they're slightly smaller solar panels. So these are the old ones that I've used. These I think are rated around about, I think it might be 100 milliamps. These are rated around 160 milliamps, both 2 volt. So both able to, via the QX5252, they're able to charge a nickel metal hydride battery. So I'll repair this, and then what we might do is I've got all the bits and pieces for a new one here. So we'll test the new solar panel out in the light. There's actually a little bit of sunlight around today, and see if those specs are actually realistic, and then we might swap that in for a new light. And I just use these cheap food storage containers from the local supermarket. I think it's like 4 of these for $5 or something like that, and they're pretty hardy. I've got a giant puppy that sort of uses them as soccer balls quite unwittingly as she moves around the house. So and they survive that. So that's what we use, and we'll put it all together, and then we'll see if it works. All right, so this is the old solar panel, and if we just connect that up, we see how many volts. It's rated as a 2 volt solar panel, and we're getting 2.3, which is good. And then I've got a 20 ohm resistor in there, so I'll just select current, and with a 20 ohm resistor we have 86 milliamps going through it. Okay, so that's the old one. The new one is smaller and also cheaper, and we'll just check the voltage first. So it should also be 2 volts, and we've got 2.3 volts, exactly the same as the old one. And then I'll check the current, and theoretically it should be a bit higher, and it's 102 amps. So that's a good result. It's smaller, cheaper, and more current going through, which means that we have a shorter time with the same amount of sun to be charging the battery. So good result. So here's the circuit, which, if you've been watching the blog, you'd be fairly familiar with at this stage. And I just made it up into a PCB. There's quite a few variations, but this is the one that I'll be using today. So first order of business, though, is to actually put some wires onto this solar panel. Unlike the older one, there are no wires that come with it, so I've just connected up a red for the positive and a black for the negative. So I'm going to do the usual time lapse of putting this together. Start with the diodes using a 6V2 Xena diode, and the 1N518
Schottky. So that's the QX5252 gone on. Now the battery connector.
Right, so I've assembled that now, including the little egg on the end here. I think this is a 1 watt LED, and I haven't put a current limiting resistor in there because the QX5252 together with the inductor here, what value you choose there, that will determine the current anyway. So yeah, so very simple. Now I haven't put the solar panel in because you don't, strictly speaking, need it to have this circuit work. So if you just want to run this off old batteries, then you can. So I've got an old battery here. So this one here, let me just see. It's just come off the clock project, so it's pretty dead for that. Am I getting anything? Oh, okay, so about 1 volt, which is fine for this dual thief circuit. So I'll just throw that in there. I've just made it a little bit darker so you can see the light coming out of that. Let's put that in, and there we go. It doesn't seem very bright, but at night time, that is enough to light, a hallway, or a room for that matter. So you can put that anywhere. And that battery, even though it's practically dead, it'll be fine in there running at that same brightness for probably a few days, if not a week or more. So yeah, if you like squeezing the last out of your AA batteries, this isn't a bad circuit. But I'm going to go ahead and put on the solar panel now, the new one, so that I can put a nickel metal hydride in there. And yeah, let's do that. So that's the solar panel fixed on the top, not symmetrically, so that's that's not good. But anyway, and then yeah, I'm just about to hot glue the rest on, and I think we're pretty good to go. So I just put a dab of hot glue under here. I have played around with lots of different glues, and yeah, probably this is not the best glue, because on a hot summer's day, and you do get them here in Tassie, this just comes off. So I'll probably go over this with a like a 2-part glue or something like that later. I'll try and still experimenting really to find a glue that's going to work. But that's pretty much it. So now I'll just see if I've got a, oh, here we go. So I've got a nickel metal hydride here. So I'll pop that in. It's not quite set, that glue, but anyway. And then, yeah, so when I cover up that light, we get a fairly bright light. I'll just turn off this one. And there you go. So as soon as the light is sensed, it goes out. And then when the light is covered, or the solar panel is covered, that light comes on. So that's a win. Pretty straightforward, works well, got them all over the house. Power supplied by the big yellow in the sky. Not such a bad result.
So that's the circuit working, and it's going to be interesting to see how these new solar panels work out side by side. I think it looks nicer. So yeah, we'll just see how it goes long term. See you next time.